In this video, we're going to talk about writing an equation that generates the sequence. You'll see that written in a lot of different ways. In this case, finding the nth term of a sequence, writing the rule of that generates the sequence, write the equation. These are all different ways to say the same thing. So what we have right here, 1357, is the sequence itself. These are the term values. And so what you're going to have to think about it is these are outputs. And they correspond with inputs. There's nothing indicating that there's anything before this 1. So we're going to operate under the assumption that 1 is our first term. So up here we have n, our variable. That's our input. And a sub n, that's our output. So the second term is 3, the third term is 5, the fourth term is 7, and the nth term is a sub n. So what we want to write is, at the end of the day, we want to be able to figure this out. We want to be able to plug a value of n in and generate that sequence. So at the end of the day, we're going to write a sub n equals something, something, something in terms of n. And in this particular case, we're just going to feel our way through it. As we go on into later chapters, later sections in this chapter rather, we're going to come up with specific ways to do this. But right now, we're just going to feel our way through it. How can I write a rule that gets me from 1 to 1? And the same rule should get me from 2 to 3, from 3 to 5, from 4 to 7. So we want a consistent rule. We want a consistent rule that gets us from n to a sub n. And in this particular case, maybe perhaps we've figured that out by now. It is 2n minus 1. And it will work for all cases. So if we wanted to then find, I keep going back to this, the 100th term in this sequence, it would simply be 2 times 100 minus 1. So in this particular case, 199 would be the 100th term of this sequence. All right? But the answer is a sub n equals 2n minus 1, just like that. So let's just dive through a few more. In this particular case, we're doing the same exact thing. We want to get from n to a sub n. And we want to write a rule that takes us from n to a sub n in a consistent manner. So just start thinking your way through it. In this case, I could take n and double it to get to there, but immediately that breaks down here. You need to do more of it. Maybe it's double it and add 1. Well, that doesn't really happen because it works for 2. Triple it and add 1. Quadruple it. Ooh, maybe I'm on to something. This seems to be 1 bigger than a perfect square. So, because 1 squared is 1 plus 2. 2 squared plus 1, 3 squared plus 1, and that will hopefully lead it. You need to know your perfect squares. So what the big thing is, it can't be 2n because it breaks down. It can't be 3n minus 1 because that breaks down. So those both break down. So you can just guess and check in this particular instance until you get to a sub n equals n squared plus 1. And that will be the rule that applies for all of these cases. And now let's look at one more before we move on to some practice on writing sequences. So here we have it. In this particular case, we need to write the nth term of this sequence. Same exact directions. We need to write a sequence that gets us from n to a sub n. So what might that be? Well, Remember, we can always think of 1 as 1 over 1 to make it look like a fraction like all the others here. And what you'll probably see, hopefully see, is that the denominator of each of these is simply n. And now we are seeing some oscillating behavior happen. We're seeing some oscillating behavior happen. So what you're seeing is that the odd term numbers are the negative values. So we are seeing -1 to the n power to make the term either positive or negative. So that way our odd terms are negative, and our even are positive. So let's just, for fun here, what would happen if I change this to +1, -1/2, +1/3, -1/4? Just throwing this one out there. So somehow you would need to make the even terms the negative ones. Well, one slick way to do that is to take this sequence and modify it just ever so slightly. There's two ways you could achieve this. You could just simply add 1 to the exponent so that when you input an odd value of n, the exponent becomes even. Or you could simply keep that the way it was. You could just plop a negative into the denominator. Or a negative out front would also get the job done. So this is another one of those times when just because I present to you one single solution doesn't mean it's the only one. So that is how we write the rule to generate a sequence, or the nth term.